Well, welcome, pre-calculus students and general seekers of truth. We will continue working on. We will continue working on our knowledge of logarithmic and exponential functions, and this time we're asked to graph a log function, log base 2 of x. And if you're unfamiliar with this, a good way to approach it is to start working on a table of values. So let's say I have x and I have f of x. And I hope at this point you're fairly familiar with the logarithms. And we can put in some numbers here. So what if x is equal to 1? Well, log base 2 of 1, log base anything of 1, will be 0. And then log base 2 of 2 will be 1. Now log base 3 of 2 is going to be kind of tricky, so I'm going to stick with the powers of 2. So log base 4 of 2 will be, log base 2 of 4 will be 2, and then log base 2 of 8 will be 3, and so on. So I will translate that into my graph over here. Let's see, here's my y-axis, and then here's my x-axis. And I will label some points here. So 1, 2, 3, 4, 5, 6, 7, 8. And we know that 1, 0 is on there. And we can go 1, 2, 3. And then 2, 1 is on there. And then 4, 2 is on here. And then 8, 3 is on here. Okay, so it looks like that. And as always, we should also try some negative numbers in here as well. Oh, but wait a minute. You can't take the log of any negative number. So for example, -1, log of -1 is undefined. There are no such thing. Okay, so we've already talked about this in some of the previous works. What about log of 0? Well, that is also undefined. Log base 2 of 0 is also undefined. So we should try some very small number, maybe 1/2. Okay? Well, log base 2 of 1/2 turns out to be -1. So what this hopefully tells us is that, and this is using just some inductive reasoning here, that I'm going to have these dots that get really, really close to the y-axis, but never actually touch and never actually cross over. Okay? So drawing this very carefully, I have a graph that looks like this. This is the graph of f of x equals log base 2 of x. And when you think about this, this generally does make sense because we cannot take the log of 0. We cannot take the log of a negative number. We've tried some table of values and it starts to level off, and it's increasing, but it starts to increasing a little bit slower. And so now we're ready to answer these questions. The domain is not all real numbers, but rather from 0 to positive infinity. And the range is all real numbers this time. And the end behavior, well, the limit as x approaches infinity of f of x is infinity. And the limit in the other direction here, I guess this isn't really an end behavior, but we should write this limit in here. The limit as x approaches 0 from the positive side of f of x will equal negative infinity. Now, this graph looks eerily similar to a graph that we may have seen before. Let me rewind this for you. Right, so if you look back at what we did before in the couple videos before, the graph of 2 to the x is this blue curve that goes like that. And the graph of log base 2 of x is this curve that looks like that other curve but curves up like this. So let me draw in the other graph just so that we have some comparison here. So I think we might be onto something. So we know that 0, 1 is on that other graph, 1, 2 is on that other graph, and a few other things. But the log base 2 graph, or the 2 to the x graph, looks something like this. Okay. And it's not surprising that it looks like that. It should look like that. It is very very familiar. Okay, so if you notice, and I didn't draw this perfectly, but these two functions are inverses of each other. They are, in fact, symmetric over the y equals x line. Right? And if you notice here, all of the points here, 1, 0 for f of x, 0, 1 for the blue curve, 2, 1 for the log function. I'm going to rewind here. 1, 2 for the exponential function. 4, 2 for the log function. And it shouldn't be a surprise, 2, 4 for the exponential functions. Okay? So one major point that we can take away from this is that log base b is any number of x, is the inverse of b to the x. So I guess we'll call this f and this one g. It doesn't really matter how you name them. The point is that those functions, these equations, they are actually inverses of each other. The input of one is the output of each other. The domain here for log is 0 to infinity. The range for the exponential is 0 to infinity. The domain for the exponential is all real numbers. The range for the log is all real numbers. And so this leads us to a very, very important point here, that the log function and the exponential functions are in fact inverses of each other. So we will have one more video in this lesson that talks about how do we compare different types of log functions with each other.